Okay guys, so today me and my group will discuss this paper which is 970952 February March 2020. But specifically for me, I will only discuss pages 2 to 4. Okay, for number 1, there are 40 members of a club which include Ranuf and Said. All 40 members will travel to a concert. 35 members will travel in a coach and the other 5 will travel in a car. Ranuf will be in the coach and Said will be in the car. And how many ways can the member who will travel in the coach be chosen? Okay, as you can see in total there are 40 members. But Ranov and Said is already chosen. So 2 members are already out of the equation. So 40 minus 2 is 38. And for the coach in total there are 35. But Ranov is already chosen. So 35 minus 1, which is 34. So 38 choose 34, which is 73,815. Okay, for the number 2. An ordinary fair die is thrown repeatedly until a 1 or 6 is obtained. A. Find the probability that it takes at least 3 throws, but no more than 5 throws to obtain 1 or 6. Okay, as we can see that from the first statement, it is a geometrical distribution as the experiment is repeatedly done until it is a success. And the probability of the success is 1 over 3 as obtaining a 1 or 6 on a die is basically 2 numbers out of the 6 numbers on a die, which is the same as 1 over 3. Okay, and it is stated that at least 3 throws but no more than 5. Basically, it is saying that it's between 3 and 5 throws. So px equals to 3 plus px equals to 4 plus px equals to 5. So 1 success, 2 fails, 1 success, 3 fails, 1 success and 4 fails. And as you can see, the probability of failing is 2 over 3 as it is 1 minus the success. So 1 minus 1 over 3. Basically, it is 2 over 3. And of course, we power it by 2 as it's 2 over 3 times 2 over 3 as there are 2 fails. And this is to the power of 3 as there are 3 fails. 2 over 3 times 2 over 3 times 2 over 3. And this is to the power of 4 as there are 4 fails. So yeah, basically the result will be 76 over 243. On another occasion, the die is thrown 3 times. The random variable x is the number of times that 1 or 6 is obtained. Okay, so it is us to find the probability distribution table for x. Okay, so there will be of course 0, 1, 2, 3 for x as 0 is the probability that 1 or 6 is obtained 0 times. 1 is the probability that 1 or 6 is obtained 1 time. 2 is the probability that 1 or 6 is obtained 2 times. And 3 is the probability that 1 or 6 is obtained 3 times. Okay, so the probability of x equals to 0 is 2 over 3 to the power of 3, as there will be 3 probability of fail, as the die is thrown 3 times and 1 or 6 is not obtained at all. So the probability of fail to the power of 3 as the die is thrown 3 times, which the answer is 8 over 27. For px equals to 1, it's 2 over 3 to the power of 2 times 1 over 3 as there are, of course, 2 fails and 1 success. So basically, it's the 2 fails will be 2 over 3 to the power of 2. And the 1 success will be 1 over 3. And it will be, of course, times by 3. So 12 over 27. For px equals to 2, there will be 1 fail and 2 success. So 2 over 3 times 1 over 3 to the power of 2. And it's, of course, times 3 again as the die is thrown 3 times. So 6 over 27. For px equals to 3, basically, the 1 or 6 is obtained on all the 3 times that the die is thrown. So 1 over 3 to the power of 3, which is 1 over 27. And after getting all of these probabilities, we can input it on this table right here. For expectation of x, it's basically the sum of this table right here. So basically 0 times 8 to the 8 over 27 plus 1 times 12 over 27 plus 2 over times 6 over 27 plus 3 times 1 over 27, which in total will lead to the answer of 1. Okay, for number 3. The weights of apples of a certain variety are normally distributed with mean 82 grams. 22% of these apples have weight greater than 87 grams. Okay, for 8 is asked to find the standard deviation of the weights of these apples. Okay, as it is a normal distribution, so here we have the x normal distribution, the mean and then the variance, which is standard deviation to the power of 2. But we haven't found the standard deviation yet, so we cannot find the variance. To find the standard deviation, we only have this data here to help us, and also this data. Okay, so Px greater than 87 grams, which is the weight, and it's greater, so we have use this symbol right here. So probability of Z greater than uh, the 87 grams, we can use the formula of uh, the x minus the mean over the standard deviation. So 87 minus the mean, which is 82, over the standard deviation, which we haven't found yet, which is 0.22. However, to match the MF19, as the MF19 cannot detect the one with the this symbol right here, it can only detect with the one with the less than symbol. So we can just reverse this sign, and then for the probability, it is 1 minus 0.22, as it is normally distributed. So it's 0.78. So the probability of Z less than this right here is 0.78. And then we can just reverse the formula to find what the value of Z less than is what. So Z less than 0.772, we can see it from the MF19. So 87 minus 82 over the standard deviation is equal to 0.772. So 5 over standard deviation is equals to 0.772. For the standard deviation, we can just reverse the formula and get 5 over 0.772, which is 6.48. Okay, for the last number B, find the probability that the weight of a randomly chosen apple of this variety differs from the mean weight by less than 4 grams. Okay, so basically the formula, like I said, is x minus mean over the standard deviation. And as it is said, differs from the mean weight by less than 4 grams. So the x minus mean will be plus minus 4. But we can just input it directly, as the formula is x minus mean over the standard deviation. So P, probability of Z between minus 4 over standard deviation and positive 4 over standard deviation. But we already found the standard deviation here. So we can just input it into this right here. The standard deviation is 6.48 to 2 decimal places, but however, the actual answer is 6.477 for the standard deviation. And right over here, we can just calculate it directly for the decimal form, so that we can use the MF19 to find the Z. Okay, so as you can see, the 0.6176 is the result from the negative 4 over 6.477. And to find it here, we can find probability of Z less than 0.6176, which is this area right here. But however, that's not done, as we need to find this middle area and not this whole area. And how we may do that, you may ask. We can just minus this whole area right over here with this small area, which is 1 minus 0.7317. So this whole area, which is 0.7317, minus this small area, which is 1 minus 0.7317, and the answer is 0.463. Okay, I think that's all for my part, as the pages of 2 to 4 is now done.
Hi everyone, introducing myself. My name is Beatrice and I will be guiding you through question number 4 and question number 5. So let's start. Richard had 3 blue candles, 2 red candles, and 6 green candles. The candles are identical apart from their colors. He arranges the 11 candles in a line. A. Find the number of different arrangements of the 11 candles if there is a candle at each end. So we can arrange this into R. Then you have 9 blank spaces, which indicates the random candles that can be put into there. And R. That means we have a total of 9 empty spaces that we can put in. So we can put 9 factorial divided by, since it is stated in the question that there are 3 identical blue candles and 6 identical green candles, so we must place in 3 factorial multiplied by 6 factorial. Put this value into your calculator and we will get the value of 84. And that is the answer to question number 4A. Now let's move on to B. Find the number of different arrangements of the 11 candles if all the blue candles are together and the red candles are not together. There are several ways to do this question, but here will be my explanation on how to do it. So first, we can find the arrangement of when the blues are together. So arrangement of blue together. Then you will subtract it with the value of the arrangement when both blue and red are together. So blue and red together. So these will be the values that we will have to find following this. So when we would like to find the arrangement of the blue together, it means that the blue will be together, and since there are 3 blue candles, we can arrange it as 1 and then blue, 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 then 1, 2, 3, 4, 5. Correct. So in here, we will consider this as 1 place. And now we have 9 other empty spaces. So we will put 9 factorial divided by, since the blue has not been considered, that means we have 2 other red candles and 6 other identical green candles. So we can put this into our statement. So 2 factorial multiplied by 6 factorial. That will be the arrangement of blue together. Next, we will have the arrangement of blue and red together. So we can duplicate this arrangement. Duplicate this and we will move it to here. Then we'll add in two other red candles. So 1 and 2. And here is considered as one arrangement. So when we look back, we will have 1, 2, 3, 4, 5, 6, 7, and 8 other spaces. So in here, our formula would be 8 factorial divided by 6 factorial, as our remaining candles will be the 6 identical green candles. Now, we can place them all together into one singular place. Now, and then you subtract them. So the value of the first one will be 252 when you put in your calculator, which you will subtract with 56. Then you subtract both of the values and you will get 196. And that is the answer for number 4B. Moving on to number 5. In Greenton, 70% of the adults own a car. A random sample of 8 adults from Greenton is chosen. A. Find the probability that the number of adults in the sample who own a car is less than 6. So we can look at the probability of when P is 6, when P is 7, and when P is 8. To do the short version, we can do the inverse of it, when usually you will find the probability of 0 and up to 5. But here we'll find 6, 7, and 8, then we'll subtract them from 1. So our arrangement will be 1 minus P6 plus P7 plus P8. When you find P6, it will be 8 because the total number of samples will be 8 adults. So 8 choose 6 multiplied by 0.7 because they are the probability of an adult actually owning a car. In other words, it's the probability of success. So 0.7 to the power of 6 multiplied by 0.3, which is the failure, to the power of 2. Place in the values into your calculator and you will get 0.2965 rounded to 4 significant figures. Now, for probability of 7, it will be the same as probability 6, except it will be 8 choose 7 multiplied by 0.7 to the power of 7 multiplied by 0.3 to the power of 1. And put these values into your calculator and you'll get 0.1977. Lastly, for probability 8, you'll put 8 choose 8 multiplied by 0.7 to the power of 8. Put this values into your calculator and you'll get 0.05765. Add these three values together and you will get 0.55185, rounded to 5 significant figures. After you have the total, we will put back into 1 minus 0.55185, and your final answer would be 0.4481. Now, we have to round it to 3 significant figures. That's why our final answer will be 0.448. Now, that is our answer for number 5A. Now, for our last question, 5B. A random sample of 120 adults from Greenton is now chosen. Use an approximation to find the probability that more than 75 of them own a car. So when they say approximation, we can use the binomial way, meaning we'll need to find the mean and the variance value. To find the mean, we will use the formula n multiplied by p. N represents the number of samples, which will be 120, multiply the probability, which is given from the previous question, which is 70%, which is equivalent to 0.7. So we will multiply it by 0.7, which is equals to 84. Now we shall find the variance. Variance has the formula of NP 1 minus P. Our NP value has been found, so it will be 84, 1 minus 0.7. This will become 84 multiplied by 0.3, which will become 25.2. To find the standard deviation, we will need to square root it. So standard deviation is the square root of our variance. Now we will find the probability for this. So based on the question, find the probability that more than 75 of them own a car. So we can place into this statement, P is X larger than 75. Because we are using approximation, so we will use continuous correction, where when the value is larger than something, then our sample value will be n plus 0.5. So n here is 75. So we will use 75.5 subtract by 84 divided by square root of 25.2. The formula for this will be n minus the mean divided by your standard deviation. Put this value into your calculator and you will get PZ is larger than negative 1.693. Now you will have to use your normal distribution chart to find the value of 1.693. Since there is a negative value, we can switch the sign into z as smaller than 1.693. And you will need to find it into your chart. You will get the value of 0.9548. Since this is in 4 significant figures, we must change it into 3 significant figures, where our final answer will be 0.955. And that is the end of question 5.
Alright. Hi everyone, my name is Kana and today I'll be explaining pages 8 to 11 of 9702 February-March 2020 variant 5.2. So let's start with the first question, which is question 6A. Box A contains 7 red balls and 1 blue ball. Box B contains 9 red balls and 5 blue balls. A ball is chosen at random from box A and then placed in box B, and a ball is then chosen at random from box B. The tree diagram below shows the possibilities for the colors of each of the balls chosen. Complete the tree diagram to show the probabilities. So here we're given a tree diagram to complete. And what I did first is calculate the total amount of balls in both box A and box B. So it's mentioned here that box A contains 7 red balls and 1 blue ball. So that makes a total of 8 balls in box A. Then we have 9 red balls and 5 red blue balls in box B. So that makes a total of 14 balls. And we should plus 1 ball, which is from A, because it says here from box A and place into box B. So plus 1 ball, and that makes 15 balls. So then we can complete the tree diagram. For box A, there's a probability of 7 per 8 for red and 1 per 8 for blue. And in box B, there is first a probability of 10 per 15 of getting red, then 5 per 15 for getting blue, and 10 per 15 here is from 9 plus 1, because we're adding 1 red ball. And then the next probabilities we can get is 9 per 15 for red and 6 per 15 for blue. And 6 here is from 5 plus 1 of the blues. So that's how we complete the tree diagram. Now let's continue to question 6B. Find the probability that the 2 balls chosen are not the same color. So probability not the same color can be probability of getting red and blue, or probability of getting blue and red. As we can see from the tree diagram, probability of getting red and blue is 7 per 8 times 5 per 15. And get a probability of getting blue and red is 1 per 8 and 9 per 15. So that makes the probability of not getting the same color is 11 per 30. So let's continue to C. Find the probability that the ball chosen from box A is blue. So this is our first event here. Given that the ball chosen from box B is blue. So this is our second event here. And here we can use P, event A, which is A is blue, given that B is blue. That's the second event. So the formula for conditional probability is probability A intersection B, or we can also write it as probability event 1 intersection event 2. We just out of probability B, or in this case, probability event 2. So we should remember this formula. And probability A intersection B is 1 per 8 times 6 per 15. So it's here. 1 per 8 times 6 per 15. And probability B is getting a blue ball, which can be here, 7 per 8 times 5 per 15, or 1 per 8 times 6 per 15. So we can get the probability of this two events is 6 per 41. Okay, next is page 10, which is question number 7. Helen measures the lengths of 150 fish of a certain species in a large pond. These lengths, correct to the nearest centimeter, are summarized in the following table. Draw a cumulative frequency graph to illustrate the data. So we can see here that the data are not connected to each other. I mean, they are connected, but they're not continuous yet. So it can be shown here from 9 to 10. They're not connected. And from 14 to 15, they're also not connected. So what we can do is we can extend the class width a bit from 0 to, so plus minus 0.5. So from 0 to 9.5, 9.5 to 14.5, and so on. And here we're supposed to draw a cumulative frequency graph. So how to make a cumulative frequency graph is first finding the cumulative frequency. So how to find cumulative frequency is from 0 to 9, the data is 15, as seen here. To get the next cumulative frequency, we can simply add 15 plus 48, which gives us 63. And then we can continue that by 15 plus 48 plus 66 to get 129. And plus that again to get 150. So this is what the graph will look like. And remember that the graph should cover at least 70% of the space given. So we should make the right scalings. And for the x-axis, don't forget, for both the axes actually, don't forget to give the label, which is length and frequency in this case. And the graph will look somewhat like this. Okay, going on to our next question, which is 7b. So 40% of these fish have a length of dcm or more. dcm or more. Use your graph to estimate the value of d. So what we can do here first is calculate how many fishes have the length dcm or more. And because it says here 40% of these fish, the total amount of fish here is 150. So 40 per 100 times 150 means that 60 fishes have lengths dcm or more. But then we can only use this graph to find how many fishes have a length of less. How do I say it? Like, how many fishes have lengths lesser than a specific length? So in this case, we can calculate how many fishes have lengths lesser than dcm by 150 minus 60. So that makes it 90 fishes have lengths lesser than dcm. And we can use the graph to find that. So you can first pull a line from the frequency 90, and it will give us a length of around 16. in the mark scheme is 16.5, but it's okay because we can make it plus minus 0.5. So 16 is still acceptable. Okay, next question. The mean length of these 150 fish is 15.295 cm. Calculate an estimate for the variance of the lengths of the fish. So what we can do here is first we have to find the mid value. And from the table given to us just now, we can find the mid values from the class widths. For example, how did I get 4.75 is from 9.5 divided by 2 is 4.75. And we can continue it with the rest of the class widths, which give us mid values of 4.75, 12, 17, and 25. And since we're already given the mean, we can use the formula of variance, which is sigma x squared times frequency out of sigma frequency minus mean square. So that gives us 4.75 squared times 15 plus 12 squared times 48 plus 17 squared times 66 plus 25 squared times 21 out of 150, which is the total frequency, minus 15.295 squared, which is mean square. And that gives us a result of 29.1. And that sums up our past paper for today. I hope this video is useful for us all. And chayo!